Alright, in this video we are going to address the measure lines and beat lines for our graphical staff.
So what's the difference between the two, just at a glance?
Well, the measure lines are going to be drawn once per measure, and beat lines are going to be drawn on every single beat. So you'll actually get to see the measures divided up into individual beats.
So like in 4/4 time, you'd get 4 sections for each measure?
Exactly.
Gotcha.
So you'd go from the outset, you would draw a line on every measure, but then you'd subdivide that with additional lines so that you could visually see the individual beats.
And this is an important thing for games like our drum game, and you've seen it before in games like Rock Band and Guitar Hero, where you see those lines coming down that you can kind of tap your foot to get the rhythm. But they're helpful in that as notes come down, if they're offbeat, if you get those kind of weird, kind of syncopated rhythms and things like that, you can tell just at a glance that you need to be ready for some sort of thing you got to play that's not quite on the beat.
Exactly. It visually holds everything together. So, to get started, let's jump into Render Horizontal, which we currently have open here inside of Visual Studio, and let's see what we need to do in order to start drawing some markers on every measure and every beat. Now, the task at hand seems simple enough because we've already got functionality such as our getStaffPosition method, which will plot out any tick value we would like on screen. And of course, all we're going to be doing is drawing ticks that happen to fall on things like measures and beats. Now, where things get a little bit more complex is that we do not want to draw markers across an entire song. A song may be hundreds or thousands of notes long, and we don't want to actually fill out that many calls.
Right. Just like our background texture, we only want to see the area that's being drawn on the screen.
Exactly. So we need to come up with a scenario where we can match the speed of our staff as it's drawing, but make sure that we only draw within the area that's visible on screen. So in order to do that, we need to get a better idea of working with individual measure units of time. We need to get a good idea of watching time go past on screen. Now, the way we're going to do this is by taking the current song's cursor value, the current song tick, and then using that multiplying that by the distance in an entire measure. Then we'll do that in such a way that will snap measure by measure, meaning when we start off the song, we stay at tick 0 until measure 1 is finished. Then we stay at tick 384 until measure 2 is finished.
Okay.
So we need to write some code in order to facilitate the snapping of the song cursor. So before we get into the implementation itself, because when we put this together, mathematically, it's not immediately obvious what's happening. So let's put together a theoretical scenario. So I guess it'll be less than theoretical once we type it out. Let's make an integer called value, just a very generic looking number. And let's set this number to be equal to song.cursor. And we're going to do something really interesting with this number. We'll take the song cursor and divide it by 100. Then we'll turn around and we'll multiply it by 100. Now, looking at this, mathematically it seems like we're going to come up with song.cursor on the other side. If we divide something by 100 and then multiply it back, we should be at our starting point. Now what we have to keep in mind is that song.cursor is an integer. Both of these numbers are integers. That means we will be doing integer arithmetic as we perform this operation. And of course, in integer arithmetic, integer division will cause us to truncate any remainder that may be present. For example, if we had a song cursor value of, say, 103, that's not going to divide evenly into 100.
Right.
So we're going to truncate any remainder and just end up at 100. So in order to see what this looks like, the way the value looks as time progresses, let's put together a few lines to draw two pieces of text to the screen so that we can watch the song's cursor and the value at the same time and see how they differ. So let's jump into our sprite batch and make a draw call. We'll draw using, let's do a draw string to draw text. We'll draw using the style.fontSmall font. And first, let's simply draw out the song's cursor. Song.cursor.toString. For position, let's drop this around the center of the screen up at the top. We'll make a new vector 2, and we'll place this at 640 in X and 0 in Y. And let's just drop in a color of white, because again, this is just for debugging purposes. Alright, now that we've got this draw call in place, let's duplicate it so that we can look at what is in our value. So we'll also run value.toString, but we'll drop it down in Y to about 20. So now as we're watching the game play out, we should see two values at the top of the screen. The song's cursor, and then this value, which should be snapping to units of 100. So let's jump in and see what this looks like. Give it just a second to build and launch our game. Now we can jump in, and we can see that here at the top, we're watching the song cursor progress rather quickly, but then every 100 ticks, we see the bottom number advance. So basically, we stay on tick 600 until we reach tick 700. So we see that we do, in fact, have some snapping in place. Now, in order to demonstrate all of the offsets we're going to be using, I'm going to set off the code to use our original pattern, our original song as a test pattern. So what I'm going to do here briefly is jump into the game and switch back to the original song, or beat 1. So here we'll bring up screen game, and we'll change the beat generator to look at beat 1 instead of 3. And this should get us the 120 tempo song with our simple drum rhythm. Alright, with this in place, let's now bring this back into the world of measures. Instead of using the arbitrary value 100, let's drop in the number of ticks in a measure. So we'll replace this with song.ticks per measure. So we'll divide by ticks per measure, and then turn around and multiply by ticks per measure. Now if we run the game, we should see that we have a larger amount of time passing before we increment. And then there's a first increment to 384, then 768, and so on. So this is matching the measure value currently used by our song, which we could very briefly review by bringing up the song class and seeing that our default ticks per measure is 384. So, all well and good, but we're still looking at simple numbers. Also, to record this more appropriately, I'm going to change our numeric value to measure tick. Because that way we could say that as long as we are within measure 1, that measure's tick is going to be tick 0.
Okay.
As long as we're in measure 2, that measure's tick is going to be 384. So we have a stable number that changes only when the measures change.
Okay.
And let's see. We'll leave the debug text lines around for just a minute longer. As a matter of fact, let's change the bottom one to show our measure tick. Alright. Now that we've got this measure tick, let's see what this value would look like if it was plotted onto the screen. Let's drop down another integer, this one called measure x. And let's set that to be equal to a value positioned using our getStaff position. So let's say this is equal to getStaff position. For tick, we'll feed in measure tick. We'll feed in track 0 since we're not going to worry about the y coordinate. And we'll pass in the current song. Now we're only interested in x, so we'll pull the x component out of this vector 2. Then we'll need to make sure we cast that floating point component over to an int. Then we can store it in measure x.
Okay.
Now we can turn around and draw a line using measure x. We'll put together a call to spritebatch.draw, where we will draw the fill texture. So style.fillTexture. We need to make a rectangle to describe the area that this line will fill, so we'll make a new rectangle, and we will position this rectangle in x at measure x. At y, we're going to place it at the top of the staff, which is currently given by span y. We'll give it a width of 1 initially, and then we'll set its height to be span height. Then for the color, we already have a color value ready for a measure marker, so we'll look into style colors, and we'll pull out beat mark measure. Now let's jump into the game and see what this line looks like. We have this fine, it may be a little bit hard to see at the moment, but we have this line that jumped to 384 and then continued to jump off the screen.
Okay.
Now to make it a little bit easier to see on the recording, we're going to temporarily make all of these markers a lot larger and a lot easier to see. So right after calculating our measure X and then drawing it, let's take out 1 and let's drop in our note width. And that gives, if we jump into the game, a much more defined marker that we can see progressing and then off the screen. Now one last thing we have to do, since we're drawing this as a rectangle, we'll offset the width to make sure that it lines back up with individual notes. So we'll take our measure X and we will subtract from that we'll decrement it by the note origin. So measure X minus equals note origin dot X. And note origin contains floating point components. We'll cast that to int. Now if we watch the marker as we jump into the game, it's centered up at our hit line. So this will simply keep things in line as we're testing it. We'll pull out this offset once we go back to the original finer marks. So I'll mark this line as temp. Alright, so far it may be a little bit confusing to watch because the measure marker right now is not following the staff.
Yeah, it kind of works its way up and then disappears.
Exactly. Now, that's just to show what's happening with it numerically, because again, it does make sense that we're saying, okay, starting at 0, we're at the middle of the screen. That's fine. Then we move to the right. Well, we've moved in the appropriate number of pixels for 384 ticks. Now, in order to match this up with our staff, we have already defined the scale cursor value as a value to describe our pan. So we could take our line where we're calculating measure X, and we could subtract scaled cursor from that. And that should apply our horizontal motion to this measure X value. So if we jump in now, we see that the measure line is following our song, and then every measure's worth of distance, it repeats.
Right.
What's interesting about this is visually that looks like a result very similar to applying modulus to the width, much like we did with the texture's own background. But the reason we're not using modulus here is we need everything to line up to actual tick-based values, not pixel-based values.
Gotcha.
In order to maintain the necessary accuracy, excuse me, we need to make sure that we're always calculating from actual song ticks. But we can see here now we've got a combination of a snapped value with the screen pan value, so the two are working together and keeping the measure line on screen. Now, of course, we need more of these lines, and we'll need to adjust them. So let's move on from here and take a look at what's necessary to begin to fill out the screen with these markers. Just like we did with the song background, we're going to run the actual drawing of the markers in a loop, and we'll use that loop to draw the appropriate number of markers to fill out the screen, or drawing until we hit the right-hand corner of the screen. To do this, we'll drop in a while loop. And we'll say while measure X is less than global state dot fixed drawing width, then we'll continue drawing measure markers. Now, at the moment, we're in an interesting scenario where we're defining measure X after we're trying to use it, so that means we'll actually have to move the definition of measure X before the loop. So we'll make an integer measure X, set that to 0. That way we do have the variable in existence before we look at it in the while loop, and then we'll simply take out our definition inside the while loop and just modify the variable. Now, with this scenario, we have to make sure that we do increment measure X, otherwise we're going to be in an infinite loop. Here we're calculating it once, and then we're never advancing the current tick. Now, in order to move on from this point to the next measure marker, we'll actually take measure tick and increment that by the number of ticks in a measure, song.ticks per measure. And then the next time we come around inside the loop, we'll apply the new value in ticks per measure using getStaffPosition, and that's what will actually advance our position in X. Now, to keep all of this code clear, I'm going to drop down a few comments. We'll drop down above the actual drawing code, that it's here where we're going to draw the measure. Then in the advancement, excuse me, we'll drop down a note saying that we're going to advance to the next measure. And while we're at it, while we're dropping comments in, let's drop in right above the measure tick line and note that this is where our measure and beat lines are going to go. So measure/beat lines. And there, that'll help keep things straight because already we've got a few calculations going and there's only more that need to be added. Alright, at this point we should be able to test and see our measures progressing all the way off the right-hand side of the screen. So if we jump in, we watch the first measure walk on the screen, and now we have multiple measure markers being drawn.
Nice.
And so as it's looping, it's looking almost correct, but if you look really closely on the left,
Falling off a little early.
they're dropping out of existence before we reach the left side of the screen. Not to mention the fact that when we initially start, we have a lot of blank area before the markers pick up. Now, to make that drop off on the left side of the screen a little bit more apparent, let's adjust our draw scale so that we can fit more markers on screen at once. So over here in config.xml, let's change our timescale value to 0.5.
You meant timescale instead of draw scale.
Oh, exactly. I don't even think we have a draw scale value, do we?
Not really. Not like that.
That's what I get for thinking 2 steps ahead. But yes, you are indeed correct. That is timescale. We'll set that to 0.5. And now if we run the game, we can see that we do have a lot of space before everything links up, and now we can see the measure markers dropping off very quickly. So really we're getting one measure's worth of distance past the hit line, and then the measure is dropping off and we move on to the next measure. So we're going to need to address this. And the way we'll do that is we'll calculate the distance from the center of the screen to the left side of the screen in terms of whole measures. Basically come up with a value that will describe how many measures we need to shift in order to begin drawing at the left of the screen instead of just after the center. So, in order to do this, let's jump in right after we calculate our measure tick, and let's put together a new variable which we'll call measure width. So the idea here is that we also pre-calculate the width of a measure in pixels, and we'll do that by measuring the number of ticks in a specific measure and multiply that by time scale. So we could say the width of a measure is given by song.ticks per measure times time scale in order to convert those ticks into pixels. Time scale is a float, so we'll take the entire operation, drop it into parentheses, and cast it over to an integer. Alright, now that we can see the width of a specific measure, let's now use that width and figure out how far we are from the left side of the screen. And it's that amount of jumps that we'll use to shift everything. So we'll make a variable called shift count, and we'll set this to be equal to the number of jumps it would take to get from the center of the screen out to the left. So basically, we already know that the center of the screen, if we think about it, is going to be 640 pixels.
Mm-hmm.
If we divide 640 by the width of a specific measure, then we'll get a number saying, well, how many jumps we need to make. How many measures in width are progressing from the left to the center. So we can take our screen center value and divide that by our measure width, and then that will give us the number of times we need to jump to get to the left of the screen. Alright, now that we've got this shift count value, let's take the current measure tick and jump it back, or decrement it enough to reach the left of the screen. So we'll take measure tick, and we will decrement this by the width, or excuse me, the ticks in a single measure, multiplied by the number of jumps we need to make, which is shift count. Alright, let's take a look and see what this looks like. So we'll jump in here, looking at our game, and everything is looking a lot better. Now there is still a little bit of space off to the side. If we jump back and forth really quick, it's a little bit hard to see at this rating, but keep your eye here over to the left, noticing the amount of width between each marker. As we jump back and forth, you can still see that there's a bit of a discrepancy. We have a bit of empty space left.
Yeah, we miss a mark at the very, very beginning of the song.
Now the reason for this is because of the lead-in time. We've got this lead-in offset, just like we had to deal with the texture background itself. Now, a very simple way we can deal with the lead-in, remembering that the lead-in time is equal to one measure in length. So we could very simply adjust our shift offset here. So we could take ticks per measure times shift count. So we take the overall number of times we jump and then add 1 to that. And that extra measure will account for our lead-in measure. So we can jump in now. And looking at it, we still have just a little bit. Let me look back at our measure count. Ticks per measure times screen. So this is actually up. I see.
You want to add 1 to your measure width up above.
Yeah. So all I did was I got mixed up a little bit on the notes. What we did accidentally here is we moved 1 tick over.
Yeah.
1 tick is not quite enough. Let's move 1 measure over. That should work better. There we go. So looking at the far left, as soon as we jump in, we should have 1 measure appearing and dropping right off the screen.
Cool.
So very nice. Alright, now that we have our measure markers drawn, let's turn our attention to beat markers. Now, the drawing beats is going to be a little bit more simplistic since we've already done the hard work of figuring out where the measures themselves go. All we have to do is place the beat markers spaced within the actual measure markers. So we can actually start at the current measure marker here inside of our draw loop and then draw some additional marks at a spacing indicated by our beat ticks. So let's drop in here between the code where we're drawing our measure and where we're advancing to the next measure. We'll drop in a comment to indicate that it is here where we're going to draw our beats. Now, in order to draw the beats, we're going to run a simple loop every time we hit a measure mark, and then we're going to draw the appropriate number of beats given our number of beats in a measure. So we'll make a for loop. We'll drop in the for loop template, and we'll loop for all of the beats currently in all the beats inside of a measure. So we've got song.beats per measure. Now we're going to adjust this loop slightly, since we don't want to draw all of the beats in the measure, because the point that the measure marker exists at is itself a beat, so we don't want to be overwriting that marker. So let's take our index variable and start it at 1 instead of 0, and that'll let us skip the first element.
Okay.
Alright, now as we're walking beat per beat, we need to figure out how much of an offset this current beat is based on our measure tick. So we'll make a variable called beat tick offset and set that to be equal to the number of ticks past the current measure marker that we're currently at. So we can look at song.ticks per beat to get the ticks in a single beat, and then multiply that by I so that we can progress to the number of beats held. If we're looking at 4/4 timing, that means we're going to loop through index 1, then 2, then 3, skipping 0. So that'll give us 1 offset, then 2 beats offset, then 3 beats offset. Alright, now that we've got our beat offset in ticks, we need to convert that to a pixel value. So we'll drop down a second variable, this time called beatx. And then we'll use our getStaffPosition method to figure out where in pixels this tick exists. Now again, the tick isn't this as an absolute. This btick offset is just that. It's an offset. And it's an offset from the current measure tick. So we'll actually find the position of the measure tick plus the beat tick offset. Now we're not worried about a track, so we'll specify track 0. We will pass in the current song, and then we'll address only the x component of the resulting vector 2. Now we also need to remember to cast this over to int before storing it. And just like we did here with the measure's position itself, we're going to cause a panning value by subtracting the scaled cursor. So we'll say minus scaled cursor. Then before we draw the beat itself, we're going to do the same thing we did with the measure. Since we're drawing much thicker high contrast marks, we'll take this beatx and subtract from it the current note origin. This is simply to center up the thicker mark on the notes themselves. And once again, we'll cast this to float. Alright, now that we have calculated our beats pixel location, we're finally ready to draw it. So we'll make a called spritebatch.draw. Once again, we'll be drawing using the fill texture, so we'll reach into style and grab the fill texture. We need to make a new rectangle to describe where this mark goes, and all this is going to be very much like the measure itself. So we need a value in x, we'll drop in beat x, and now from here on out we should be able to look at the same things we're doing up here inside of our measures drawing. So that means starting at span y, giving a note's width, and then drawing over the span height. So we'll drop in span y for our y component, note width for our width component, and span height for the height of our rectangle. Now for the color, we'll drop in style colors dot beat mark, and that will take care of our draw call. Alright, at this point we should be ready to test, so let's jump into the game, and there we go. Now we have a lot of lines on screen.
Yes, we do.
So we have a slightly darker beat marker inside of the measure marks. So in this case we can see 3 beat marks inside of each measure mark, and then if we count the measure mark as a beat itself, that way we're getting 4 beats per cycle, and then that's visually representing our 4/4 timing.
So what happens if you switch this over to Beat Generator 3, which was using 6/8 timing?
We'll check that in just a minute, but yeah, keep that in mind because we do need to verify that we're getting the right marks.
Okay, that was shut up for now, Zach. That's what that translates. I hear that a lot around the office.
But I mean, that brings up a good point. We do need to test that, but we've got a few things to clean up before we get there.
Okay, cool.
First thing to clean up is if we look really closely at the left of the screen when we start up, just for a second you can see that we're missing some individual beat markers. Now to make this easier to see, let's change our time scale and let's increase it a little bit to a value of 1. So we'll drop in 1.0 for the time scale. We'll also jump into the beat generator and slow the current song down. So over here in beat generator, currently we're using generate beat 1. Let's drop the tempo all the way down to 40. Now we can see that we're once again missing a bunch of space on the left of the screen.
Mm-hmm. So we're going to do the same thing we did with the measure lines?
Exactly. What's happening is we're giving ourselves enough measure lines, but the problem is to start off with those beat markers, we have to have an imaginary, well, I guess in this case a real actual measure marker that's drawn off screen to give the point from which we draw the necessary beat markers to fill in that original gap.
Well, because you're kind of dividing up the space between those measure lines, and now there's nothing to divide.
Exactly, because there's no measure that far off the left of the screen. Now, to compensate for this, we can simply add another measure that we jump off screen, and that'll make sure we jump far enough off screen to have the room to draw the beat markers. So now if we jump in, we can see that the first line on the far left is actually a beat marker. Alright, so now we're getting, actually that gets us pretty close to the end. We now have our beat markers put in. Let's take out the high contrast settings and set all of our scaling back to its original setting.
You're going to make the lines thin again?
Yep. So let's jump in here and take each case where we're originally drawing the measure marker. We'll take out note width and replace that with a value of 1. We'll do the same thing for our beat marker, draw them with a value of 1, and then we'll drop out our additional offsets. So where we're decrementing beat x, that line gets removed, and the point where we're decrementing measure x, we'll take that out as well. Now while we're adjusting things, let's also jump into our config and change our time scale back to its original value of 1.5. And I guess while we're fixing stuff, we could also jump into the beat generator and turn our tempo back up to 120. Alright, with all of these changes in place, let's jump in and see what the final result is. So we can see we have much thinner looking lines. They will look very faint because we have the scaling where we're taking our 1280 internal resolution down to our funky 901 res.
Yeah.
Then we have additional scaling that's being applied to the video recording itself.
Mm-hmm.
But the idea is the same. We've got the same spacing we had earlier. We're just drawing these at their actual value. So we're drawing them at 1 pixel values to match the track separators themselves. But again, jumping into it one last time, we can now see where measures start and the lines on which individual beats occur. So now we actually have a time frame where we can place all of our notes. And now I know these notes at the bottom aren't actually offbeat, but it does kind of demonstrate the point you were mentioning earlier, where having these lines to reference beats makes it easier to tell where notes should go. So looking at these bottom kick notes where we have kick eighth notes, you can tell that there's something up with that note placing because it's not landing on a beat marker.
Right.
So you can actually tell that it's sub-beat.
In this case, we're also running into the situation of building something at a large resolution and then downscaling when your line is around a pixel wide, and you're starting to get a little bit of shimmer in your lines.
Right, it's going to look like the lines will get a little bit fuzzy or shimmery in certain cases, and this is simply because we're taking a large image and scaling it down. Now we're getting a degree of subsampling just by nature of the way the hardware is handling textures, but that's just one of the design artifacts. Generally, you wouldn't want to have a native resolution that much higher if you were actually going to deploy the game at a 800 by 600 resolution.
Not to mention that if you knew you had to downscale, you wouldn't want any of your lines to be as small as a single pixel. So if you run into a situation like this and changing your resolution just isn't viable, then you may want to consider taking your lines and making them maybe 2 pixels or maybe all the way up to 3, so that when they downscale, they can remain small without getting that kind of half-pixel style shimmer.
Exactly. All right, now let's get back to what you had mentioned a minute ago. Does this system handle different time signatures? To see whether or not that's the case, let's jump to our screen game and change back to generate beat 3. Now if we jump in and run the game, well, we definitely have a different looking set of beats. The beats are actually, they physically look wider because of the increased number of ticks in each beat. And looking at it, we would, on this screen, on the recording screen, we would almost have to bring back the high contrast lines to see where measures are landing, but if you look real close, you can see that there's only one beat marker in between each measure marker.
Right.
So that means we're getting only 2 beats per measure, but that's what we set in our time signature for beat 3. We've got, if we go over to our beat generator and scroll down to beat 3, we can see that the beats per measure is set to 2. So our actual visual staff is matching up with our settings here.
Okay.
While we're in here, I'll go ahead and grab the 2 debug notes. We put 2 additional sets of notes on track 0 for crash, and track 7 for ride. We'll go ahead and pull those out. And while we're fixing stuff, we could also bring our song's tempo back up to 100. We had added the additional notes, of course, earlier when we were testing the renderer. Now that we've got the renderer working, we can set all of these values back. So that results in a final, original representation of our pattern. Now we still have those debug numbers drawing at the top, so let's jump into our renderer horizontal and clean those up as well. So up here, actually we've left these below the loop. We'll kill out our 2 sprite batch draw string lines at the 640 location because we no longer need those debug numbers. Alright, one last thing to do before we bring this video to a close, and that is drawing the start line marker. We're actually going to draw a visual mark on screen to indicate the first note of a song. This can also be useful to help debug certain songs, because you're supposed to have the measure lead-in given by lead-in beats, but there's nothing preventing you from placing notes after tick 0 or skipping tick 0. So we're going to add a visual marker whether there's a note there or not to say that, okay, this is the point at which the song begins. So what we'll do is we'll jump in here right before we draw our hit line, and we'll drop down a comment to indicate that we're going to draw what we will call the start line. Now drawing the start line is actually rather easy. We're going to give ourselves a position, actually we're simply going to use the center of the screen and then pan that value based on our scaled cursor. So we'll take our sprite batch, make a call to draw, grab the style.fill texture. We need to describe this line using a rectangle, so we'll make a new rectangle. And for the X, we will start at the screen center, but then we will subtract the scaled cursor, and that should give us our panning value. Also, the interesting thing is we're subtracting scaled cursor, which starts out at negative because of our original negative cursor. So that means our start line will actually start to the right of the screen, which will match up with the song itself. Alright, we need to specify our Y value, so we'll drop in span Y. We'll give a width of 1 and a height of span height. Now we've got a color prepared in the style colors struct, so we'll drop in style colors dot start mark. Alright, so let's jump into the game and see how this is looking. And the pattern goes by rather fast, but we can see that there is a line drawing at the beginning of the song. Let me jump in and change our game back to beat 1. There, that moves a little bit more slowly. But even though it zips by pretty fast, we can see that there is a red line indicating the first note, or rather, the start of the song itself.
Okay.
Alright, with that, we have our staff markers drawing. We've got our start line drawing, and so that is going to wrap up the renderer horizontal class. We've got everything we need in place for notes, for positioning notes, for drawing all of the graphics on our staff, things such as backgrounds, markers, and so forth. So that is going to bring this lesson to a close.